So we're continuing notes 10-4. This time we're talking about composite shapes. So you're using all the things you learned before in all the other sections and we're putting them together in composite shapes. The reason why, well, sometimes rooms, houses, they have little notches, spaces in them. Sometimes you have to calculate. So anyway, let's move on with this. We want to find the dimensions of an irregularly shaped pool. So we want to find the area of the surface of the pool. And if you notice this shape, if you look at it, you've got two semicircles and you've got a rectangle and a triangle. So I can find the surface area of this pool if I can just find out what the area of each of those pieces are. So the trick is not seeing the shapes, but finding the actual dimensions that go with them. If you notice, the radii on these circles are not labeled, but there's one dimension in there that's the same. So let's go through this. We have two semicircles. So if you think about that, the two semicircles together would be a circle. So the area of the circle is pi r squared. So we're going to use that formula. Then we also see a rectangle. The area of a rectangle is the formula base times height. And then you see the area of a triangle. So the area of a triangle is 1/2 base times height. So we're going to take all of these and add them together to find the total surface area. So the area of the semicircles together makes a circle. If you notice, the 16 right here is out there, but it's also the same as the diameter. So the diameter is 16 feet. The radius then is 8. So the area equals pi times 8 squared, which is 64 pi. In this lesson, we're going to go with exact dimensions and then also decimal. So you can see the difference in what they look like again. So this would be exact. The rectangle at the base of this is 32. That 16 that was the diameter of the semicircle is also the height. So the height equals 16. So the area of this one is going to be 32 times 16, which equals 512. Then the area of the triangle is 1/2 base times height. So the base of the rectangle is the same as the base of the triangle. So the base equals 32. The height of that triangle is over here. It's the 15. So this equals 1/2 times 32 times 15, which is 240. Then you're going to take all of those areas and add them together. So you have the area of the circle, plus the area of the rectangle, plus the area of the one triangle. So that equals 64 pi, plus the rectangle, which is 512, plus the area of the triangle, which is 240. So if we're going with exact dimensions of this, because remember exact means you haven't rounded anything, you haven't used the pi or anything, you're going to combine like terms. The 512 and the 240 are like terms, so this is 752. And then the 64 pi, we typically leave it like that, treating the pi as a x, just like you would as a variable. Oh, and then we add the units, so this should have let me erase that box. This should be feet squared. If you do this exact, or if you do this in your calculator, it will be rounded 953.1 feet squared. So this is exact. This is rounded. So typically, again, if we have to round any at all, we call it rounded. Exact, sometimes we ask for exact, sometimes we ask for rounded. Just follow the instructions in the work that you're given. Okay, find the area of the figure in square feet. Pause your video, try this one, make sure you can do it. All right, so what I see in here is I see a semicircle. I see a rectangle. And I see two triangles. The semicircle, the area of that will equal 1/2 of pi r squared. The radius of this one, the 18, is the same as the diameter, so the radius of this one is 9. So the area of this one is 1/2 times pi times 9 squared, which is 81/2 pi. The rectangle, area is base times height. Base equals 18. The height equals 8. So I'm using these two dimensions. So the area of this one, when I put these in, it's going to be 18 times 8, which equals 144. The area of the two triangles, I'm going to do 2 times the area of 1/2 base times height. So really, if you can see that, it's base times height is all you're doing. The base in this case is the 5, and the height is the 8. If that confuses you what I just did there, then just go ahead and find the area of one triangle and double it. So the area equals 5 times 8, which equals 40 for the area of the two triangles. And then you total these all together, and you end up with area equals 164 plus 81 over 2 pi. If you're going exact, then that would be feet squared. If you're going rounded, it's 204.5 feet squared. Then we get to these last two ones. Notice that each of these has kind of a hole in it. So on the first one, you've got the big rectangle and a little rectangle. So if I want to find the area of the shaded figure, I'm going to take the area of the big rectangle minus the area of the little rectangle. So for the little one, it's pretty easy to see that the base is there and the height is there. Okay, so the area of the little one is going to be 100 times 20, which is 2,000. The area of the big one, though, you got to find the height and the base, or the base and the height. So if you notice, I can put 100 right here, and that's part of that base. The other part of that base is this distance right here, and this distance right here. So it's 25 feet all the way around. So I'll check that. Okay, so this is 25 feet all the way around. So that means for the area of the big one, this is going to be the base equals 150 because I added those together. Then we're going to do the same thing for the height. So the height of this one, if you notice, that tall is 20. So 20 of the height is the same as that whole. But then we're going to add 25 onto the top and 25 onto the bottom. So the height of this is 70. So the area of the big one is 10,500. So now to find the area of the total shaded area is 10,500 minus 2,000. and that equals 8,500 square feet. This last one, it involves your triangle areas that you did before. So notice that this is area of a circle with the triangle subtracted from it. So the total area equals the area of the circle minus the area of the triangle. The area of the circle, easy peasy, because the radius is 5. So this is pi times 5 squared. But we have to find the area of that triangle. So off to the side here, we're going to draw just the equilateral triangle. So that's our regular polygon, which is what we were doing last time. And notice that the radius of that is 5. We still need the apothem, and we need to know the perimeter because this is the formula that we're going for. The central angle of an equilateral triangle is 360 divided by 3, which is 120. So each of these angles right here is 120 degrees. But for that triangle, we want to just use half of it. So this is 60 degrees right here. The apothem is here, and the 5 is here. So I've taken this triangle and I've pulled it out. This is a 30, 60, 90 triangle. The 5 is on the 2s hypotenuse side. The a is the same as the s. This other leg is s times the square root of 3. So s, if I use this, must be 5 over 2, or 2.5. So s, or the apothem, equals 2.5. And then the other leg is 2.5 times the square root of 3. So let's take this back to our big triangle picture. The apothem is 2.5. Half of the side is 2.5 times the square root of 3. So that means the whole entire thing of that, the side, is 5 square roots of 3. So for this triangle, I'm using this formula. The apothem equals 2.5 because that's the line that's perpendicular to the side, and the perimeter is 3 times 5 square roots of 3, which equals 15 square roots of 3. So the area formula for this one is 1/2 times 2.5 times 15 square roots of 3. If I simplify that, I get 25 pi for this one, minus 18.75 square roots of 3. So exact is done. Rounded is going to be 46.1 inches squared. This is exact. This is rounded. Okay, like I said, look at your instructions, see which ones they ask for, rounding to the nearest tenth usually, or 100th they say, and then it might say exact. And that's it.